Hello and welcome to TelecomTV. We're here at Mobile World Congress 2017 here in Barcelona and in Spain. And I'm talking with John Healy of Intel and Dr. O of China Telecom. Gentlemen, welcome to you both. Glad to see you. Good to see you again, John. And Dr. O, it's good to see you and meet you for the first time. I'm going to start with you, if I might. I wanted to refer back to the joint demo you held with Intel earlier this year. Can you tell us what it was about, what the purpose of it was?
This demo is a rack-based NFV structure total solution. It includes three parts. The first is the pre-integrated, pre-validation, carrier-grade, large-scale rack itself. Is a big in the NFV device area. The second is the carrier-grade total, or we call it all-in-one solution for NFV, including the compute nodes, storage network, and resource pool management. The third is a multiple telecom typical scenario support scenario in our rack show. You can see VMS, VBRS, and so many telecom and supporting system inside the rack. I think this is a very important step for the carrier. It's first time for them to design a special professional provide a device for their own, according to their own idea. Of course, the idea coming from many sides, including the RSD idea from the Intel and the total solution direct from the Innsbruck. I think this is the first time carrier to design their own solution in the NFV area. It's also increase the management in granularity to be an individual node level, increased to a bigger rack level, and easy to be extended to the pod level. Resource pool management is increased the efficiency of management and deployment. So we're very glad to see to be deployed in the near future in the field trial.
It's being said that after all the hype, 2017 is the year that NFV will be deployed properly commercially on a wide scale. But there are still some obstacles on that roadway preventing that happening immediately. Can you tell us what those obstacles are, do you think, and how will you overcome them?
The big obstacle mainly coming from the decoupling everything, every layer, from the hardware management, virtual layer, and VNF management and orchestration. Decoupling everything, so we have to reassemble everything. So it's big integrate and or interoperability testing become very big effort for us. Not only for us, for China Telecom, China Mobile, Unicom, AT&T, other carriers, the similar situation. We have to assemble everything, and we don't know how to make the efficiency on the management level and service providing level. So I think the RSD technology provides us possibility to provide capability to manage the rack across different vendors, the first, and increase the granularity of management to individual nodes to a large-scale rack. Yes, easy to explore to a big resource pool, so it's favorable and encouraging thing for us. Yes.
Yeah, I think they're really well-made points. I completely agree. Clearly, a tremendous amount of progress has been made, and we're seeing that this year at the show. So many new applications and so many different types of virtual network functions are being implemented together. But you're right, there are still some challenges to overcome. What China Telecom have done in this demo, embracing an architecture like rack scale design with the configurability and the resource pooling and management that's made available, plus the integration and implementation of multiple vendors' VNFs is a great step in the direction of what's required across the industry to truly create interoperable solutions. So the challenges we see are things like VNF onboarding, the need for a more capable scheme for onboarding multiple VNFs from multiple different vendors to truly create an interoperable set of solutions for the market. There's a lot of work going on there, more required around the management and orchestration layers. The other that was already mentioned is then the challenge of scale, truly deploying at scale across the industry so that the level of ruggedness and service assurance and scalability can really be reinforced and ensured in how these implementations come to market. Again, work is well underway there, but more work is to be done. And the last I'll mention is this need for constantly, deriving the right kinds of metrics and performance parameters and business implication parameters. Some will call it TCO, total cost of ownership. Others will say it's a performance analysis to allow the industry to have a standardized way of looking at the consequence of deploying NFV at scale to their business, so that the range of investments required to really fuel the growth and the scale that's really in front of us can be best informed and best reinforced. But these are being addressed. There's more work to be done with them. We're very, very excited about the progress we're seeing this year.
Dr. O, this one's for you again this time, if you would please. I'd like to talk to you about the CTNet 2025 vision that was introduced back in July of last year. Can you tell us what that was about and how China Telecom transformed under the terms of that vision?
Because too many uncertainty in the decoupling phase, for example, the hardware layer don't know what kind of the VIM they have to shoot for, and the VIM don't know what kind of environment, hardware environment, and upper layers, FVO or the VLFM layer. So we have to destroy this very bad loop chain here. I think the first step is we should customize or make the hardware layer become standard at the first step. So we introduced RSD technology here to make a rack level measurement. So in case of any vendor lock and in case of any uncertainty of this loop. So I think it's a very big step for us to define a large-scale professional FV infrastructure device in a standard way. Easy to be deploy service on that, easy to deploy the cloud management on that. I think it's very important for us.
The last question, John, goes to you. Can you tell us what Intel technology helped China Telecom in that network transformation process?
So really, as Dr. O has said, there are a number of challenges that you have to be able to accommodate. And the technologies we bring really are across the entire stack. Of course, there are the technologies within the platform themselves, the CPU, the associated technologies within the CPU to really help network workloads to be accelerated to perform exactly where we expect them and need them to be, whether that's in the virtualization layers, whether that's within the packet processing with frameworks like the Data Plane Development Kit or DBTK, virtual switching support, and even all the way through to the network resources with the Ethernet components and the support for elements as well. Where it really all comes together is how you can bring those technologies and implement them in a framework like RSD, exactly what this demo is describing. The ability to compose those resources up through the orchestration stack, and a lot of the work we do is technology contribution into the orchestration and control layers as well, like work with OpenStack and that community and others like Open Daylight from a control perspective. And of course, with all of the VNFs that we described here in this demo, there's work involved in helping those software vendors to optimize their functions with the technologies that exist inside the platform. And it's through the harmonizing of how that virtual function can operate, taking advantage of the technology, ensuring it can be managed through the orchestration layers, and then the pod management and the resource allocation within RSD that takes advantage of the underlying assets of the platform. It's truly in this top to bottom view from application right down to platform that those technologies best present themselves to help to solve some of the challenges that exist in building out a next generation infrastructure. So what we're seeing through the demonstration here is really all components of those elements coming together and being manifest in a multi-vendor interoperable way.
Gentlemen, thank you very much indeed.